Do aliens really exist? This is a question that has baffled humanity for centuries. Since time immemorial, we've looked up at the stars, wondering if we're alone in this vast, seemingly infinite universe. Is Earth the only stage where the drama of life unfolds, or is there another audience in the cosmic theater, watching with bated breath? Our fascination with extraterrestrial life is not merely the stuff of science fiction. It's a question that scientists, philosophers, and curious minds across the globe have grappled with. The idea of life beyond Earth challenges our understanding of existence and compels us to expand our horizons beyond the familiar. In today's video, we're setting out on an interstellar journey. We'll explore various pieces of evidence, from complex scientific equations to mysterious aerial phenomena, that suggest we may not be alone in the universe. So hold on to your seats as we delve deep into the cosmos and seek answers to this enduring question. Ever heard of the Drake equation? No, it's not a new song from the Canadian rapper. This equation is a scientific formula, not for beats, but for beats of life pulsing somewhere in the universe. Created in the early 60s by astronomer Frank Drake, not for the purpose of quantifying the number of civilizations, but intended to stimulate scientific dialogue at the first scientific meeting on the search for extraterrestrial intelligence, SETI. This equation takes into account factors such as the rate of star formation in our galaxy, the fraction of those stars with planetary systems, the number of planets that could support life, the likelihood of life developing, the probability of that life developing intelligence, the fraction of civilizations that develop technology that releases signals into space, and the length of time those signals would be released. When we plug in the numbers, even with conservative estimates, the equation gives us a result that suggests we are far from alone. The sheer scale of the universe, with its billions of galaxies, each containing billions of stars, makes it statistically likely that other intelligent life forms exist. Of course, the Drake equation is not without its critics. Some argue that it is too speculative or that our understanding of these variables is too limited. But it does provide a framework for thinking about the possibilities of extraterrestrial life. So, if mathematics is anything to go by, we are not alone in the universe. But wait, if there are so many potential civilizations, why haven't we made contact yet? Enter the Fermi paradox. This paradox, named after physicist Enrico Fermi, deals with the contradiction between the high probability of extraterrestrial life and the startling lack of evidence or contact with such civilizations. Consider this. There are billions of stars in our galaxy alone, many of which could potentially host habitable planets. If even a tiny fraction of those planets developed intelligent life, there should be a multitude of civilizations out there. Yet, here we are, seemingly alone in the vast expanse of the cosmos. This is the crux of the Fermi paradox. To explain this paradox, some scientists have proposed the Great Filter theory. The idea here is that there's a sort of cosmic speed bump that prevents civilizations from lasting long enough or becoming advanced enough to reach out into the stars. This could be anything from a natural disaster to self-destruction through war or environmental damage. The implications of the Great Filter are chilling. If it's behind us, we're one of the lucky few to have made it this far. But if it's ahead of us, our civilization may be doomed to the same fate as all those who came before. It seems we are stuck in a cosmic catch-22, doesn't it? We yearn to find intelligent life beyond Earth, yet the silence of the universe might be the very answer we dread. But let's not forget about those mysterious sightings in our own skies. Unidentified aerial phenomena, or UAPs as they're commonly known, have been the subject of intense debate, fascination, and intrigue for decades. Formerly known as UFOs, these phenomena have been reported in countless cases around the world, and their existence is no longer the stuff of science fiction or wild imagination. Interestingly, some of the most credible reports of UAP sightings come from those trained to observe and understand the skies, military personnel, and pilots. These individuals, with their extensive experience and knowledge, have reported encounters with objects that moved in ways that defy known laws of physics, at speeds unimaginable, and without any visible means of propulsion. And it's not just anecdotal evidence we're talking about here. There's been video footage, radar data, and even physical effects on the environment that remain unexplained. All these point to something real, something tangible, yet something we don't fully understand. Perhaps the most significant development in recent years has been the acknowledgement by governments, including the United States, about the existence of these phenomena. These are no longer dismissed as mere hoaxes or misinterpretations. There's a growing acceptance that UAPs are real, although their nature and origin remain shrouded in mystery. While not a confirmation of little green men, these UAPs certainly add to the mounting pile of intriguing evidence. And then of course there are exoplanets and extremophiles. Exoplanets, or planets outside our solar system, have long captured our collective imagination. With the launch of telescopes like Kepler and TESS, we've identified thousands of these distant worlds, and a handful of them even reside in the Goldilocks zone, where conditions might be just right for liquid water, and possibly life, to exist. But what kind of life could we expect to find on these alien worlds? That's where extremophiles come in. These hardy organisms, found right here on Earth, thrive in conditions that would be lethal to most other life forms. From the scalding hydrothermal vents at the bottom of our oceans to the freezing deserts of Antarctica, extremophiles have adapted to survive and even flourish in the harshest environments. These discoveries shift our perspective on where life can exist. If life can thrive in Earth's extremes, why not on a distant exoplanet with similar harsh conditions? The discoveries of exoplanets and extremophiles have expanded our understanding of habitability beyond our own blue planet. They've shown us that life doesn't just survive in the face of adversity, it thrives, it adapts, it evolves. As we continue to explore the cosmos, each new discovery brings us one step closer to answering the question, are we alone in the universe? It seems that life, as they say, finds a way.